China is shooting for the moon. The country plans to put its own astronauts on the moon by 2030. The Chinese government says its lunar ambitions have now been kickstarted as it races to meet the goal.
In a world where science and technology are opening up new frontiers, we find ourselves on the brink of a new era in space exploration. While the United States has long been at the forefront of space achievements, China is emerging as a formidable contender with its remarkable recent feats. And today, we present you a development that will reshape our understanding of space. But before we go any further, don't forget to like and subscribe to our channel. China's journey into space began in the 1950s when it started developing rocket and satellite technologies. Fast forward to November 29, 2022, and we witnessed the completion of the awe-inspiring Tiangong space station. This modular space station, also known as China's Heavenly Palace, is the third permanently crewed space station in orbit, surpassing the complexity of its predecessors. With a T-shaped structure, it boasts a length of 220 feet, a width of 150 feet, and a weight of 60 tons, operating in a stable orbit about 250 miles above Earth. Designed to support up to 6 astronauts, it also holds immense potential for commercial activities such as space tourism and telecommunications. China's rapid ascent in space exploration is evident in its launch spree, surpassing 200 rocket launches in the past decade. This surge is directly linked to the construction of the Tiangong space station, making China a strong competitor to SpaceX, which launched 61 missions in 2022 and aims for around 100 in 2023. China's ambitions are reaching new heights with plans to deploy over 100 microsatellites equipped with X-ray telescopes. The Space-Based Multi-Telescope Array (SMTA) project, led by the Chinese Academy of Sciences, will revolutionize our understanding of deep space phenomena by detecting X-rays emitted by energetic cosmic objects like black holes and supernovae. These microsatellites will provide unprecedented insights into their formation and evolution. With a budget of around $1 billion, this project showcases China's commitment to innovation. China's private space company, Landspace, made history on July 12, 2023 by successfully launching the UK-2 rocket, powered by methane. This groundbreaking achievement puts China ahead of US companies like SpaceX in the race for methane-fueled rocket technology. The UK-2 rocket is a medium-lift powerhouse capable of carrying up to 6,000 kilograms to low Earth orbit. What makes this even more exciting is that methane is a cleaner and more abundant fuel than traditional rocket propellants, making it an excellent choice for reusable rockets. Landspace's success with the UK-2 rocket is a significant milestone in advancing rocketry. In May 2021, China marked its name in the history books by becoming the second country, after the United States, to successfully land a rover on Mars. The Zhurong rover's landing on May 14, 2021, was a spectacular achievement, making it the first Chinese spacecraft to touch down on the Red Planet. After launching on July 23, 2020, and entering Martian orbit on February 10, 2021, Zhurong navigated its way to Utopia Planitia, a vast plain on Mars' northern hemisphere. The landing was a highly complex maneuver, executed flawlessly as the rover touched down softly, deployed its solar panels, and began sending back valuable data within minutes. China's lunar exploration program is making strides that no other country has accomplished in decades. The Chang'e 5 lunar sample return mission, launched on November 24, 2020, marked a historic moment as it gracefully brought lunar samples back to Earth, making China the third nation to achieve this feat, following the United States and the Soviet Union. The mission consisted of 4 modules: a service module, a lander, an ascent module, and an Earth return capsule. It collected 1,631 grams, 61.1 ounces of lunar samples, which are now being analyzed by scientists worldwide. This success has set the stage for the upcoming Chang'e 6 lunar sample return mission, scheduled for 2024, which will provide invaluable insights into the moon's early history, particularly from its south pole. China's Long March 5B, the nation's largest and most powerful rocket, has been a game-changer since its debut in 2016. On July 24, 2023, It roared to life from the Wenchang Space Launch Center, carrying the Wentian space station module into orbit. This rocket is unique in that its first and largest stage serves as the upper stage, a feat unmatched by any other. Weighing over 23 tons, it became the heaviest rocket stage to re-enter Earth's atmosphere uncontrolled. Intriguingly, China launched the Shijian-21 satellite, its first quantum communications satellite, on October 24, 2021. Although shrouded in secrecy before launch, it turned out to be a groundbreaking mission designed to test space debris mitigation technologies. The satellite's remarkable ability to dock with the defunct Beidou 2 G2 navigation satellite in December 2021, using robotic arms to tow it to a safer orbit, showcases China's contribution to reducing the risk of collisions in space. China's independent mission to Mars, Tianwen-1, was launched on July 23, 2020, marking a historic achievement. After a 7-month journey, it entered Mars orbit on February 10, 2021, to unravel Martian mysteries. The mission included the first-ever landing and deployment of a rover on Mars named Zhurong, equipped with advanced instruments for studying the red planet's geology and environment. This ambitious endeavor cost approximately $2.2 billion and has already yielded a wealth of data, including images, videos, and insights into Martian terrain. The Shenzhou 13 crewed mission, launched on October 16, 2021, is a testament to China's growing presence in space exploration. The mission docked with the Tianhe module of the Tiangong space station, featuring the first Chinese woman to conduct a spacewalk. 3 astronauts, Zhai Zhigang, Wang Yaping, and Ye Guangfu, conducted scientific experiments and spacewalks during their 6-month stay on the space station. China's rapid progress in space is undeniable, although the United States still maintains an edge in terms of spending, supply chains, and capabilities. Now let's talk about a couple of crucial factors in this technology. One of them is noise. Once you've programmed these chips and started doing matrix multiplications, you'll wonder just how much noise creeps in. Additionally, there's the issue of stability. Phase change memory, like the one used here, isn't known for its long-term stability. Resistance or conductance states can drift over time, affecting accuracy. So, how do they tackle these challenges? IBM's got a clever solution. They use 256 analog-to-digital converters, ADCs, at the output. These ADCs read the analog values and convert them to digital ones. Then, they employ digital processing to scale and offset these values per column. This helps compensate for variations between columns and counteracts the conductance drift issue. The result? A remarkable achievement, 92.8% accuracy in classical image classification tasks. That's a game changer and, as per the paper, the highest accuracy ever achieved using similar analog chip technology. Now let's talk efficiency. This chip is a powerhouse, capable of 400 gig operations per second per unit area. To put it simply, it's 15 times more powerful than its predecessors. That's a significant leap towards building more efficient analog chips for AI. But the big question is, will analog computers take over? Well, there's a lot of exciting research happening in this realm. Silicon Valley is buzzing with projects exploring analog chips' potential. However, it's still uncertain if widespread adoption will happen. To truly gauge the shift towards analog chips, keep an eye on multi-bit memory adoption. That'll be the indicator. Even if analog chips do take over, they're likely to be used for inference applications rather than training. Training neural networks on analog chips is a whole different ballgame, as it involves complex hardware functions to allow flexibility. Training chips are even more complicated and might not be as customizable as digital processors. Plus, there are challenges related to endurance and reprogramming weights during training. Digital chips, with their versatility and limitless endurance, currently seem better suited for deep neural network training.